We are going to start now the next chapter. It is chapter 5 of class 10th mathematics, and it is arithmetic progression. So the first definition we have over here, it is sequence. So sequence is, we are saying some numbers are given to us and we have arranged them in a definite order or according to a definite rule. So what we mean to say is, suppose some numbers are given to us and we have arranged them. We are saying the first term we are saying it is first number. You can say it is first term, or you can say it is the first number, say it is 2. Then the second we are saying it is say 4. Third we are saying say it is 6. Then fourth we are saying say it is 10, or say it is 8, and so on. Then what we have done, we have fixed the position of these numbers. If I am talking about 6, then its position is fixed, that it is at the third place. So this, writing the numbers in this form, that we have fixed the position arranged in a definite order, this forms a sequence of numbers. So we are saying this 2, 4, 6, 8 and so on, this is a sequence of numbers. Now the first term we can also write it as A1. We can write it like this, or we can write it like T1. So what we mean to say is, if I am saying A1 means we are talking about the first term of the sequence. If I am saying T2, it means its value is 4. This 2 represent that this is the second term of this sequence. If I am saying T3 means I am talking about the third term, and third term of this sequence is 8. Like this, if we continue, we are saying Tn will represent the nth term of sequence. In general, when we are saying Tn means it is the nth term of the sequence we are talking about. So we are saying that the number occurring at the nth place of a sequence is called the nth term, and it is denoted by Tn or An. Now next, we are given this example over here. We are saying that the rule that is given to us is that Tn is equal to 2n plus 1. So Tn means this is the general term we are talking about, or we are saying it is the nth term of the sequence. So we have to put the values of n is equal to 1, 2, 3, 4, 5, and we have to find the answer for this sequence. So we are saying the first term T1 means in place of n we are writing 1, so it is 2 into 1 plus 1. T2, that is 2 into 2 plus 1. T3, it is 2 into 3 plus 1. So what we are doing, this 1 is here, then 2, then 3. So likewise we are substituting the values, and the answers we obtain, they are 3, then 5, then 7. So we are saying T1 is 3, T2 is 5, T3 is 7, and if we continue putting these values, we will get the sequence in the form 3, 5, 7, and next value will be 9, next value is 11, and so on. So these are the terms of the sequence. So this is the rule that is given over here, that how the terms are arranged. This is the rule given to us. Next is arithmetic progression. So arithmetic progression is a special kind of sequence in which this rule we are talking about, it is some definite rule we are saying. So that rule is defined in some particular way. So the definition given over here, it is a sequence in which each term differs from its preceding term by a constant is called an arithmetic progression. So suppose the first term we are saying, say it is A. The first term of sequence, suppose we are saying it is A1. I am talking about any arithmetic progression. The first next term is A2, next is A3, next is A4, so on. General term I am saying An, and so on. So what this definition is saying, that each term differs from its preceding term by a constant. Suppose the constant we are saying that constant is d. We are saying that constant value we are talking over here, it is d. Now what this definition is saying, if I am talking about A2, it differs from A1 by this constant value d. Next we are saying this A3, it differs from A2 by constant value d. Next is this A4, it differs from A3 by this constant value d. So we are saying what is the relation between all these terms, that if we take any two consecutive terms, then the difference between those two values, it is d. So this d, it is also called the common difference. We are saying it is called the, this value of d we are getting over here, this is called the common difference of the AP. So this is the definition for the arithmetic progression. So next we have given an example of that this sequence is given to you. This sequence is given over here and we have to show that this is an AP. AP means arithmetic progression. This is short form for arithmetic progression. So we are taking first two terms, it is 11 and 8. We are subtracting these two terms and we are getting the answer is 3. Next we are considering the next two terms. We are subtracting those terms. We are getting the answer is 3. Next we are subtracting the next two terms. The next two terms, they are 17 minus 14. The answer is 3. Next it is 20 minus 17. The answer is 3. So what we see from these values is that in all the cases the answer is 3. All the cases means when this is the preceding term, this is the term, and this 8 is the preceding term for this 11. So the difference of the term and its preceding terms, for all these terms it differ by 3. So we are saying the given progression is AP. Its first term is 8. And we are talking about this progression, it is 8, 11, 14, 17, 20 and so on. First term means this is the first term, you cannot interchange the values over here, and the common difference means this value, that is the common value over here, that is the common difference is 3. It is important to note over here that all these values we are saying these should be 3. If suppose one of the values is say 2, then this is not an AP. Next, this sequence is given to us and we have to prove this is an AP. We have to find the first term and the common difference. So again we are talking about the terms over here. Suppose I am talking about these two terms. So it is 6 minus 11. Common difference we are calculating for these two terms if it is an AP. The next two terms, it is 6 and 1. So we are talking about 1 minus 6. Next we are talking about the two terms. It is minus 4 and 1. This term we are saying it is minus 4 and we are subtracting it from 1. The next value we have, it is these two values we are talking about, minus 4 and minus 9. So it is minus 9 minus minus 4. For all these terms the common difference is minus 5. So the difference we have, it is minus 5. So we are saying all these terms, that is 11, 6, 1, minus 4, minus 9 and so on. This forms an, all these numbers, these are in AP. The first term we have, it is 11 and the common difference we have, it is minus 5. Next is show that the following progressions are in AP. Progression means we are talking about sequence. Progression we can use interchangeably over here at this level. So we are saying find the common difference and the next term of each. So the first sequence that is given to us is root 7, root 28 and root 63. So it is root 7. This value we are saying it is 2 root 7 and this value we are saying it is 3 square root 7. We are saying 28, we can write it is 4 into 7, and this value it is 9 into 7. So these are the answers. Now if we calculate the common difference in this case, we are subtracting these two values, that is 2 root 7 minus root 7. So the answer we have it is square root 7. For the next two values it is 3 root 7 minus 2 root 7. So the answer it is root 7. So we are saying this is the value of D. That is the common difference we are talking about, it is root 7. Now next we have to calculate is the next term over here. So suppose we are saying the next term it is A4. Then that difference between these two terms it should be 7. It means we are saying that A4 minus 3 square root 7 should be equal to square root of 7. So the value of A4 we get it is 3 root 7 plus square root of 7, that is equal to 4 square root of 7. So this is our next term, and you can leave the answer up to this, or you can write it in the form square root of 112. Next is the sequence is given to us, it is square root of 18, square root of 50, square root of 98. We can write this term 18 as, this 18 is 9 into 2. So the value we get it is 3 square root 2. This is 25 into 2. So it is 5 root 2. This value we are saying it is 49 into 2. So it is 7 root 2. Now if we subtract these two terms, that is 5 root 3 minus 3 root 2, the answer we get it is 2 root 2. Similarly, if we subtract these two terms, the answer we are getting 2 root 2, and these are the values of D we are talking about. So these are the common difference. Now we are saying suppose the next value we have it is A4. The common difference between these two values will be 2 root 2. It means A4 minus 7 root 2 is equal to 2 root 2. So we get A4 is equal to 7 root 2 plus 2 root 2. That is equal to 9 root 2, and we can write it as square root of 162. Next is find A and B such that the numbers A, 9, these are the numbers given to us. It is A, 9, B and 25, these are in AP. If these numbers are in AP, their common difference we are saying that is 9 minus A. The common difference we are saying it is B minus 9. The common difference we are saying it is 25 minus B. It is given that these are in AP. So what we get is the common difference D is equal to this, and all these values should be equal. Now from these two terms we get that 2B is equal to 25 plus 9, that is equal to 34. So the value of B we have it is 17. From the first two terms we have 9 minus A is equal to B, 17 minus 9. So the value of A we have it is, we are shifting A on this side and all these terms on this side. So it is 9 plus 9 minus 17 is equal to 1. So the final answer we get that A is equal to 1 and B is equal to 17. Next is arithmetic series. So by adding the terms of an AP, we get the corresponding arithmetic series. So adding the term means we are saying the AP, we are saying it is A1, A2, A3, A4 and so on. When we are talking about the arithmetic series, it means we are adding all these terms. It is A1 plus A2 plus A3 plus A4 and so on. So by adding the terms of an AP, we get the corresponding arithmetic series. So some examples are given over here, that if the AP is 3, 7, 11, 15, 19, Then the arithmetic series corresponding to this is 3 plus 7 plus 11 plus 15 plus 19 and so on. This is the arithmetic series corresponding to this arithmetic progression. Next is to find the general term of an AP, of an arithmetic progression. So we are saying if the first term of an AP is A and the common difference is D, then we have to show that the nth term of the AP is A plus n minus 1 D. Now the first term that is given to us A1, that is equal to A. Suppose the second term is A2, then what we have is that A2 minus A1 should be D. It means A2 is equal to A1 plus D. What is the value of A1? It is A. So the value of A2 we have, it is A plus D. Next we are saying A3. So A3 when we are calculating, so it is A3 minus A2. We are calculating value of A3. We are saying it is equal to D. It means A3 is equal to A2 plus D. It means it is A plus D plus D, that is equal to A plus 2 D. So the value of A3 we have is A plus 2 D. Next we are talking about A4. So A4 minus A3 should be D. So we are saying A4 is equal to A3 plus D. So the answer we get it A3 plus 3D. We are adding D to it. So we are getting the answer in this form. So if we continue it like this, we say that AN, if we are calculating the nth term over here, that is equal to, if we look at these terms over here, this first term is A, then it is A plus G, then it is A plus 2D, then it is A plus 3D. The general term we are trying to write, so its value will be A plus, when it is 4 over here, the term we are getting it is 3. When it is 3 over here, the term we are getting it is 2. So this 3 means we are writing it is 4 minus 1. 2 means we are writing 3 minus 1. 1 means, this is 1 over here, it means we are writing 2 minus 1. So when it is n over here, the value we have over here, it is n minus 1 into D. So we are saying that AN is equal to A plus n minus 1 into D, and this is the nth term. This is the formula for the general term or the nth term of an AP. The nth term of an AP, it is also called the general term. So now we move on to the next slide. So it is given that if first term of an AP is A, common difference is D, then the nth term is A plus n minus 1 D. So in the next question, it is find the nth term and the 16th term of this AP. So for this, we are saying that AP we have it is 3, 5, 7, 9, 11 and so on. From this it is clear that this is the first term, that is it is the value of A, that is equal to 3. A we are saying it is the first term. So you can also write it as A1. So in general the first term we write it is A. So the value of A we have it is 3. We want to write the nth term, so this n will remain as it is. Now we want to calculate the value of D, that is the common difference. Now we take any two values from this. Suppose I am taking these two values, consecutive values I am talking about. So the common difference will be 7 minus 5 is equal to 2. You can calculate common difference by considering any two consecutive terms. You can consider 9 and 11. The common difference is 11 minus 9 is equal to 2. We know that if it is an AP, then the common difference D, that is same for all these values. So what we have now is that the value of A is 3 and the value of D is 2. So the general term formula we have it is A plus n minus 1. This will remain as it is. We are calculating the nth term, and the value of D it is 2. Now on opening this bracket, you will get it is 3 plus 2n minus 2, that is equal to 2n plus 1. So this is the formula for the general term or the nth term. It is 2n plus 1. Now when we have to calculate the value of the 16th term, in place of n we are writing it is 16. So in this formula we will substitute, in place of n we will write 16 and it is plus 1. This value is 16, this value is 16, and the answer we will get it is 33. Now next is find the nth term and the 12th term of this AP. So the first term we have, it is 14. So the value of A is 14. To calculate the common difference, we are considering any two consecutive terms. Say I am talking about 4 and 9. Then the value of D will be 4 minus 9. You can consider 1, minus 1 and minus 6. Then the value will be minus 6 minus minus 1. So the value we have, it is minus 5, minus 5. So these are the values of D that we have. So we are saying the value of D that we have, it is minus 5. The formula for the common term Tn is equal to A plus n minus 1 D. The value of A is 14, n minus 1 as it is, and D is 5. So we are getting it is 5n plus the common difference over here, it is minus 5. We are saying this is minus sign over here. So it is minus 5n plus 19. So the common general term we have, it is minus 5n plus 19. Now next we have to calculate is the 12th term. So the 12th term, to calculate the 12th term, we are writing n is equal to 12 in this equation. So it is T12 is equal to minus 5 into 12 plus 19. So the answer we get, that is equal to minus 41. So we are saying this is our 12th term, that is minus 41. Next is find the 105th term of the AP. AP is given to us. The values are 4, 4 whole 1 by 2, 5, 5 whole 1 by 2, 6, and so on. So these are the values: 4, 9 by 2, 5, 11 by 2, 6, and so on. Now the first term we have, it is 4. We are saying this is the value of A. The common difference we will have, you can subtract any of these values. Suppose I am subtracting 5 minus 9 by 2, or you can subtract it as 9 by 2 minus 4. In all these cases, the answer I will get it is 1 by 2. So this is the value of D that we have. So the general term we are talking about, we need not to find the general term. It is 105th term we have to calculate. So it is A plus, in place of n we are writing it is 105 minus 1 into D. The formula we have, it is A plus n minus 1 D. So in place of n we are writing 105. So the answer we get is A is 4. This is 104. D is 1 by 2. So the answer we get on cancelling these two values, we are getting it is 52. So the answer we get it is 56. So we are saying that 105th term of this AP is 56. Now the next question we have, find the 25th term of the AP. The AP, the terms that are given are minus 5, minus 5 by 2, 0, 5 by 2, and so on. Now when we subtract these terms, we are saying it is minus 5 by 2 minus minus 5. You can subtract these two. It is 5 by 2 minus 0. The answer we will have, it is 5 by 2. This is minus 5 by 2 plus 5. The answer we have, it is 5 by 2. So this is the value of D that we have. That is the common difference. This is the value of A that we have. Now we have to calculate 25th term, T25 we are talking about. It is A plus n. In place of n we have 25 minus 1, and in place of D We are saying it is minus 5, this is A, plus 24 into D is 5 by 2. So the answer we have it is minus 5 plus 60, that is equal to 55. So we are saying the 25th term is 55. That somewhere this is first term, second term, third term, fourth term. Likewise, we will have some 55th term over here, and that will be 25th term over here, that will be 55. Now next is, if the nth term of the AP is, that is Tn, it is 5n minus 2. We have to find its first term. So the first term means we are talking about T1. So T1 means we, in place of n, we will write 1. So the answer will get it is 5 into 1 minus 2, that is equal to 3. The next term T2 we will have, it is 5 into 2 minus 3, and that is minus 2. This is 2 over here. We are saying in place of this n we are writing 1, then we have written in place of this we have written it is 2. So the answer we have over here it is 8. Now the common difference is 8 minus 3. We are saying the first term of this AP it is 3, next term it is 8. So the common difference is 8 minus 3, that is equal to 5. So D is 5. Next is we have to find the 19th term. So 19th term of this AP will be, it is T19, that is A, the value of A means we are talking about first term, plus 19 minus 1, n minus 1, and value of D that we have it is 5, and on solving this you will get it is 93. This is T19, we are saying it is 93. So the value of the 19th term is 93. Now in this question we are given that the 7th term of an AP is, that is T7, that is equal to 1 by 9, and the 9th term of the AP is 1 by 7. The formula we know when we are talking about the 7th term, it is A plus 7 minus 1D, that is equal to A plus 6D. This is A plus 9 minus 1D, that is equal to A plus 8D. So we have two equations now. One is A plus 6D is equal to 1 by 9, and second is A plus 8D is equal to 1 by 7. Now if we subtract these equations, we get 1 by 9 minus 1 by 7, that is equal to, this A gets cancelled and we are left with is minus 2D. Now this value is equal to 63 is over here, and it is 7 minus 9. So the answer we get is that minus 2 by 63 is equal to minus 2D. So minus 2 gets cancelled, and the value of D we get it is 1 by 63. Now if we substitute this value of D in the first equation, we get 1 by 9 is equal to A plus 6 into 1 by 63. So the value of A we get it is 1 by 9 minus 6 by 63. This is equal to 63. 7 minus 6, that is equal to 1 by 63. So we are saying A is 1 by 63, D is 1 by 63. Both these values, these are 1 by 63. So T63 we have it is equal to A plus 63 minus 1 D. A is 1 by 63. 62 into 1 by 63. So the answer we have it is 63 by 63 is equal to 1. So the 63rd term of this AP is 1. Next is the sum of the 4th and the 8th term. We are talking about the sum of the 4th and the 8th term of an AP is 24. We are talking about T4 plus T8, that is equal to 24. and the sum of the sixth term and the 10th term is 44. Find the first three terms of this AP. So what is T4? It is A plus 3D plus A plus 7D. This is equal to 24. Then A plus 5D, A plus 9D, that is equal to 44. These values we are saying these are n minus 1, n minus 1, n minus 1, n minus 1 d. So what we get is that 2a plus 10d is equal to 24 and 2a plus 14d is equal to 44. Now if we subtract these two equations, these two terms get cancelled. The left is this minus 4d is equal to minus 20. So this gives us d is equal to 5. If we substitute the value of d in one of the equations, suppose I am substituting this value of d in the first equation, I will get it is a plus 5 into 5 is equal to 12. So a is equal to 12 minus 25, that is equal to minus 13. So we get a is equal to 13 minus 13 and d is equal to 5. These are the two values we are obtaining. Now next what we have to do is find the first three terms of the AP. Now the first three terms means we are talking about this a is equal to minus 13. This is the first term. Next term a2 will be a plus d, that is minus 13 plus 5, that is minus 8. Next a3 will be a2 plus d, so that is minus 8 plus 5, that is equal to minus 3. So the first three terms we have it is minus 13, minus 8 and minus 3. Next is which term of the AP 5, 9, 13, 17 is 81. It is so on up to this. So we are talking about the first term of the AP, it is 5. The common difference of this AP, we subtract any two values over here, it is 13 minus 9, that is equal to 4. So the value of D we have it is 4. Then we have to calculate the n for which Tn is equal to 81. So this is equal to a plus n minus 1d. So 81 is equal to 5 plus n minus 1. Value of d is 4. So we get that when we shift this term on this side, it is 81 is equal to 5 plus 4n minus 4. So this is 4n is equal to 80. So this gives us n is equal to 20. So we are saying that the 20th term of this AP is 81. It is the 20th term, that is 81. Next is which term of the AP is given. The values are 3, 15, 27, 30, 9 and so on. It is which term of this AP will be 120 more than the 21st term. So the value of A we have it is 3. The value of D we have it is 15 minus 3 is equal to 12. If we are talking about the 21st term, it means we are saying A plus 21 minus 1D. So it is 3 plus 20 into 12. So that is equal to 243. Now we have to find that which term, suppose we are saying it is the nth term, which is 243 plus 120, that is equal to 363. We are talking about it is 120 more than the 21st term. So we are saying 363 is equal to a plus n minus 1d. The value of a is 3, n we have to calculate, and the value of d we have it is 12. So we get that 12n is equal to 372. When you open this bracket, it is 3 plus 12n minus 12. So the value of n that you will get, it is 31. This is the value of n we are obtaining. It is 31. So we are saying that the 31st term, it is the term which is 120 more than the 21st term. Now the next we have, is 51 a term of this AP? We have to find whether 51 is the term of this AP. It means that is there any n for which Tn is equal to 51. We want to find an n for which Tn is equal to 51. From this AP, what we have is A is equal to 5, D is equal to 8 minus 5, that is equal to 3. We are saying suppose the nth term of this AP is 51, then we have 51 is equal to A plus n minus 1 D. This is equal to 5 plus n minus 1 D. This is nth term we are talking about. So we are saying if we subtract it on this side, we get that if we solve this equation first, it is 5 plus 3n minus 3. So it is 2 plus 3n. So we get 3n is equal to 49. N is equal to 49 by 3. And we are saying this is not possible because the values of n that we are saying that should be a natural number. And we are talking about the sequence. So we are saying it will have first term, second term, third term. So in general, we are considering that the values of n or this n is a natural number. In some cases, there are some cases when we start taking n is equal to 0, 1, 2. But right now we are just interested in the sequence which have for which n is a natural number. We are not interested in these kind of sequences right now. Now the next question is, how many terms are there in this AP? So this question is basically, it is in this form that this value we are saying it is 7, 11, 15 and so on 139. We are saying if 139 is the last term over here, then we have to calculate how many terms are there. So this is the value of A we have. When we subtract these two, we get D is equal to 4. So we are saying Tn, that is equal to 139, is equal to A plus n minus 1D, that is equal to 7 plus n minus 1 and D is 4. So it is 7 plus 4n minus 4. So we get 4n is equal to 136. So n is equal to 34. So we are saying that this AP 7, 11, 15 up to 139, this AP has total 34 terms. If 139, this is the last term of this AP. Next we have find the middle term of the AP. This AP is given to us. Now it is so on up to 37. So what is basically given to us? The terms that are given are 213, 205, 197, so on up to 37. So the value of A that we have, it is this. If we subtract these two values, the value of D we have, it is 205 minus 213, that is equal to minus 8. Now we are saying suppose this AP contains n term, that is this is the term Tn. We want to calculate this value of n. So we are saying Tn is equal to 37 is equal to A plus n minus 1D. So it is 37 is equal to 213 plus n minus 1 into minus 8. So it is 213 minus 8n plus 8. So the value we get, it is 8n is equal to 184. So this implies us n is equal to 23. So we are saying this is the 23rd term. Now when we are talking about the middle term, and there are total 23 terms, then the middle term will be 1 by 2 into 23 plus 1th term. So the answer we have, it is the 12th term. Now we have to calculate the 12th term. So we are talking about T12. This is A plus 12 minus 1D. The value of A we have, it is 213 plus 11 into, we have D over here. The value of D is minus 8. So it is 213 minus 88, that is equal to 125. So we are saying the middle term of this AP is 125. Now the next we have, which term of the AP is the first negative term. This AP is given to us. It is 24, 21, 18, 15 and so on. We have to find which term is the first negative term. So suppose some term Tn is there, which is the first negative term. So we are saying the value of A we have, it is 24. The value of D we have, it is minus 3. So Tn we are talking about, it is A plus n minus 1D, and we are saying it is less than 0. So we have 24 plus n minus 1. We are talking about the least value of n for which this is 0 we have to calculate, and the value of D we have, it is minus 3, and this value we are saying it is less than 0. So we get 24 minus 3n plus 3 is less than 0. So this gives us 27 is less than 3n. So we are saying this gives us that n is greater than 9. So what is the least value of n we have? It is n is equal to 10. That is, we are saying for n is greater than 9, all the values they are negative. That is, the T10th term, T11, T12, all these terms, these are negative. So what is the first term that is negative? That will be 10th term, that is negative. Next is, for what value of n are the nth term of the following two AP the same? These are the two AP that are given to us. It is 13, 19, 25 and so on. Second is 69, 68, 67 and so on. These are the two AP they are given to us. And we have to find for which value of n the nth term of both these AP they are same. Now for both these APs we write the nth term. For this it is A plus n minus 1, and D in this case it is 19 minus 13 is equal to 6. So it is 6. In this second case, the nth term is, first term is 69 plus n minus 1, and the common difference over here, it is 68 minus 69, that is equal to minus 1. So what we get is, on solving these two values, we get that 13 plus 6n minus 6 is equal to 69 plus n minus n plus 1. So this gives us 7 plus 6n is equal to 70 minus n. So 7n is equal to 63. So the n value of n we get, it is 9. So what we get from this is that for the 9th term, both of these AP, the 9th term, it is same. Now we calculate this 9th term. So we substitute the value in any one of these. So it is 13 plus 8 into 6. So the answer we will get, it is 13 plus 48, that is equal to 61. So we are saying that term will be 61. You can also calculate the value using this formula. So we get, it is 69 plus 8 into minus 1. So it is 69 minus 8, that is equal to 61, and we can see that both the terms, these are equal. Now next is, if 7 times the seventh term of an AP, that is 7 times the seventh term of an AP, is equal to 11 times the 11th term of an AP, then what will be the 18th term? T18 we want to calculate. So from this equation we are getting 7 into A plus 6D is equal to 11 into A plus 10D. Now by solving these equations we get 7A plus 42D is equal to 11A plus 110D. It means 4A plus 68D, that is equal to 0. This is A plus 17D is equal to 0. Now what we want to calculate is, we want to calculate the 18th term, that is A plus 17D we want to calculate. And from here what we get is that this value is 0. So we are saying that the 17th or 18th term of this AP, it is 0. Next is, if the nth term of a progression be a linear expression in n, then prove that this progression is an AP. So linear expression means that the degree of n that we have, it is 1. So nth term of an AP, it is a linear term. Linear term means we are talking about it is of the form a n plus b. Yes, n is the variable over here. We have to prove that this progression, whatever the sequence we will obtain, progression over here means sequence we are talking about, if any sequence have this kind of general term, then it is an AP. So to prove it is an AP, it means we have to prove that the terms that we will have, terms means I'm talking about what is the sequence that we will obtain, it is T1 that is equal to A plus B, then T2 that is equal to 2A plus B, likewise. So we are obtaining the terms like this. We have to prove that this is an AP. So what we are doing is, we are considering any two consecutive terms. We are saying, suppose the AP we are talking about, it is T1, T2, T3, then we have some term Tn minus 1, then we have some term Tn, and so on. We have seen what is T1, next we will have T2, the value of Tn, which is an plus b, and the value of this will be an minus 1 plus b. In place of n, we are writing it is n minus 1 over here. So these are the two consecutive terms we have. So the common difference, or we are saying the difference between the terms will be an plus b minus an minus 1 plus b. This gives us an plus b minus an plus a plus b. These two gets cancelled, and what we are left with is, this is minus sign over here, this b gets cancelled, and we are left with this a, and this a is a constant. We are saying this a is a constant. So it means that the value of this common difference is constant. That is, the common difference between all these terms, the difference between all these consecutive terms, it is constant. And this is the definition of an arithmetic progression. So we are saying the given progression is an AP. Now next is, in a given AP, if the pth term we are saying is Q. So pth term is Q means we are talking about T P is equal to Q, and the qth term is P. Then we have to show that the nth term is, P plus Q minus N. So from this what we are getting is that A plus P minus 1 D, that is equal to Q. From this we are getting A plus q minus 1d, that is equal to p. Now, if we subtract both these equations, if we are subtracting, we are writing the equations again. It is p minus 1d is equal to q. A plus q minus 1d is equal to p. We are subtracting both these equations. These two gets cancelled. We are left with this p minus 1 minus q minus 1 d is equal to q minus p. So it is p minus 1 minus q plus 1. These two gets cancelled. So I left with this p minus q. D is equal to q minus p. So this gives us d is equal to minus 1. Now if we substitute this value in one of these equations, we will get the value of a. So if we are substituting these values in the first equation, we get it is a plus p minus 1 into d, that is equal to q. So the value of a we get, it is equal to p plus q minus 1. So we have these values over here, that d is equal to minus 1 and a is equal to this. Now what we want to calculate is, we want to calculate the value of the nth term Tn. So it is a plus n minus 1 d. So that is equal to p plus q minus 1 plus n minus 1 into minus 1. So this is p plus q plus, this is p plus q minus n. This is the value that we obtain for the nth term, and this is what we have to prove, that the nth term is p plus q minus n. Now the next we have, if m times the mth term of an AP, that is m times the mth term of an AP is equal to n times the nth term of the AP, we have to show that m plus nth term is 0. We have to show that Tm plus n is equal to 0. So we are saying it is m into a plus m minus 1 d, that is equal to n into a plus n minus 1 d. These values we are getting over here. So when we simplify this, we are getting ma plus m into m minus 1 d, that is equal to na plus n into n minus 1 d. Now this gives us m a minus n a, that is equal to n into n minus 1 d minus m into m minus 1 d. So m minus n a is equal to n square, we can write minus n minus m square plus m into d. So what we get is that m minus n a is equal to, or we are shifting these terms on the other side, we are saying it is plus m square minus n square minus m plus n into d is equal to 0. We have changed the sign of all these terms. So this gives us m minus n into a plus m minus n into m plus n. We are writing this term as this, and the second term we have taken minus sign common, and we are left with this m minus n into d is equal to 0. So from these two terms we are taking m minus n common, so we are left with this m plus n minus 1 d is equal to 0. So this m minus n into a plus this is equal to 0. So from all these terms we can take m minus n common, and we are left with this a plus m plus n minus 1 d, that is equal to 0. Now it is given that m is not equal to n. It means this term we are saying You can divide this whole equation on both sides by m minus n. It is 0 over here, so this gets cancelled. So what we are left with is that a plus m plus n minus 1 d is equal to 0, and this is the formula for the m plus nth term. That is general m plus n term. It is given by a plus m plus n minus 1 d, and the answer we are getting for this term, it is 0. Next is, if the pth, qth and rth term of an AP are a, b, c respectively, we are saying Tp is a, Tq is b, and Tr is c. We have to prove that this relation is satisfied. So suppose we are saying that the first term of the AP, A is already used over here, so we are saying first term of the AP, it is x. Then what we have is that x plus p minus 1d, that is equal to a, x plus q minus 1d, that is equal to b, and x plus r minus 1d, that is equal to c. These are the three equations we have. Now if we multiply the first equation, by q minus r, we multiply the second equation by r minus p, and we multiply this third equation by p minus q, and add all these three equations, what we get is, when we multiply this x over here, we are getting x into q minus x into r. We are talking about these three terms first. Next we get is plus r into x minus p into x plus p into x minus q into x. These two gets cancelled, these two gets cancelled, and these two gets cancelled. It means that all these three terms, they will result to 0. Next, for these three terms, what we will have is, when we are talking about this side, it is a into q minus r plus b into r minus p plus c into p minus q. That is equal to, when we solve these values and we are multiplying it with these terms, the answers we are getting, it is d will be common from all these, so it is p minus 1 into q minus r plus, we are saying, I am talking about this term over here, I am talking about what is the result of this, d is common from all this. Next is r minus p into q minus 1 plus r minus 1 into p minus q. D is common from all this, we are left with this pq, q minus r minus q minus r, then q into r minus p minus r minus p plus r into p minus q minus p minus q. Now from these terms, what we are getting is, these three terms, this again gets cancelled, and we are left with is p into q minus r. I am talking about these two terms, it is p into q. Over here we will have minus p into q. We are talking about this term, this is p into q, this gets cancelled. Then we have minus p into r, this is p into r plus, and this is with the minus sign. Then the next term we will have, it is, what we are left with is this term, it is r into q, and from this term we will have r into q, so this term is also equal to 0. So this whole term will be equal to 0, and this is what we have to prove, that a into q minus r plus b into r minus p plus c into p minus q is equal to 0. And this is why we have multiplied these three terms over. This is based upon this. Next is, if the mth term of an AP is 1 by n, we are saying Tm is 1 by n, Tn is 1 by m. We have to prove that Tmn is equal to 1. So from this what we are getting is a plus m minus 1d, that is equal to 1 by n. From this we are getting a plus n minus 1d, that is equal to 1 by m. Now if we subtract both these equations, we get it is m minus 1 minus n minus 1 d, that is equal to 1 by n minus 1 by m. So it is m minus 1 minus n plus 1 d, that is equal to m minus n over m into n. These two gets cancelled, this whole term gets cancelled. So the value of d we get it is 1 over m into n. Now if we substitute this value of d in suppose this first equation, we get a plus m minus 1 over mn, that is equal to 1 by n. This gives us a is equal to 1 by n into 1 minus m minus 1 over m. So this is a is equal to 1 by n into m minus m plus 1 over m. These m gets cancelled and we are left with this m into n. So we get that the value of d is 1 by mn, the value of a is 1 by m into n. Now we have to calculate Tmn, that is equal to a plus mn minus 1 d, that is equal to 1 by mn plus mn minus 1 by mn. This is equal to mn plus 1 minus 1 by mn. These two get cancelled, so it is mn over mn, that is equal to 1, and this is what we have to prove. Now the next formula we have, it is to find the nth term from the end of an AP. So we are saying if a be the first term, d be the common difference, and l be the last term of a given AP, then we have to show that nth term from the end is this. This is the formula for the last lth term. We are talking about nth term from the end. Nth term from the end means, suppose I am saying the AP we have, it is a plus d, a plus 2d, so on up to l minus 2d, l minus d, and l. This is the last term. Now we are calculating the nth term from end. It means we are considering that the AP is L, L minus D, L minus 2D, so on, A plus 2D, A plus D, and A. So we are considering this is the nth term from beginning for this AP. If we are interested in this kind of value, and we are saying the formula for this is L minus n minus 1 d. So we are saying the last term that we will have, it is L, and these are given over here. So you can look at these values over here, that how we are getting this formula. But right now you should remember this formula, that the value is for the, that how we calculate the nth term from the end, it is L minus n minus 1 d. Now the next is find the 11th term from the end of the AP. This, so the AP that is given to us is 10, 7, 4, so on up to minus 62. So we are saying we have to find the 11th term from the end. The formula we have, it is L minus n minus 1 d. This is our last term. So the answer we are getting, it is minus 62 minus 11 minus 1. We are calculating the nth term from the end, and it is minus 3. Why it is minus 3? The value of d we are getting, it is 7 minus 10 is equal to minus 3. So the answer we getting for this, it is minus 32. So to another way to solve this is that we are trying to find the value. It is, the sequence is 62, then 4, then 7, then 10, and we are trying to find the nth term for this sequence. So if we are trying to find the nth term for this sequence, we are saying the common difference we have now, it is 7 minus 4 is equal to 3. So the nth term for this, we are saying Tn will be a plus n minus 1d, that is minus 62, plus we are talking about the 11th term, so 11 minus 1 d, now it is 3, so it is minus 62 plus 11 minus 1 into 3. We are saying both these formulas, they are same. The only difference is over here we are having the plus sign, over here we are having the minus sign, because this common difference we are talking about, it is change in sign is there. The change in sign of the common difference is there because we have changed the order of this sequence. That is why the difference of answer is there. So you can directly use this formula, or you can write the sequence in this term and you can use the same formula. So it is up to you that how you want to solve these kind of questions. Now the next we have some words problems. So first is, how many 3-digit numbers are divisible by 7? So we are saying that the first number, that is 3-digit number, that is divisible by 7, it is 105. Next is 112, so on, and the last number we have, it is 994. So basically we want to find the how many terms this sequence has. So these numbers, these are in AP. Why? Because this is a plus 7, then we have this is a plus n into 7. So we are more interested, why we are saying these are in AP, because these are multiples of 7. It means if we take any two consecutive numbers, then their difference will be 7. So we have a is equal to 105, Tn is equal to 994. In the common difference we have, it is 7. So we get it is 994 is equal to 105 plus n minus 1, and d is 7. So on solving this, we will get it is 994 is equal to 105 plus 7n minus 7. So the value of n we get, it is 128. So we are saying that this term in this sequence, it is 128th term. So we have 128 3-digit numbers divisible by 7. Next is, how many multiples of 4 lie between 10 and 250. So we are saying the multiples of 4 between 10 and 250, they are, first is 12, next is 16, so on. 250 is not divisible by 4. 249 is not divisible by 4. 248 is divisible by 4. It means the last term is 248. So the value of a we have, it is 12, d we have, it is 4, and t n we have, it is 248. So we are saying 248 is equal to a plus n minus 1 into 4, and on solving this, you will get the value of n is 240. So we are saying we are getting the value of n is 60. So we are saying that there are 60 multiples of 4 lying between 10 and 250. Next is, a sum of 1000 is invested at 8% per annum simple interest. We have to calculate the interest at the end of 1, 2, 3 years. Is the sequence of interest an AP? Find the interest at the end of 30 years. So principal that is given to us is 1000. The rate of interest that is given to us, it is 8%. So we are saying that the interest at the end of n years, the formula we have, that is principal into rate into time over 100. So that is equal to, we are having these values, so it is 80 times n. N is the time we are talking about. So if we put n is equal to 1, we get interest after 1 year, it is 80. Interest after 2 years, it is 160. Interest after 3 years, it is 320, and so on. Now we are saying whether this sequence we are talking about, is this an AP? We have to prove this. So if we look at this term over here, it is 80n. This is a linear term in n. It is linear in n. It means these values, these are in AP. And we have to find the interest after 30 years. So it means we have to calculate T30 for this sequence, for which A is equal to 80. The value of D that we have, it is the value of I3 over here we have, it is not 320, it is 240. I4 is 320. So the value of D that we have over here, it is 80. We subtract these two values, we will get 80. So T30 is equal to A plus 30 minus 1D, that is 80 plus 29 into 80, that is equal to 80 plus 2320, that is equal to 2400 rupees. So we are saying that the interest at the end of 30 years is rupees 2400. Next is, Tanvi joined her job in a company in the year 2015 on a monthly salary of rupees 40,000 with an annual increment of 2500. In which year will she get rupees 65,000 as monthly salary? So we are saying in the year 2015 she has joined the company at the salary of 40,000. In 2016 her salary will be 40,000 plus 2500. We have to find in which year the salary will become 65,000. That is after how many terms we have to this value, the sequence will have the value 65,000. So what we have is the value of A, we have it is 40,000. The value of D we have it is 2500. T and we have it is 65,000. So when we put these values in the formula, we get 65,000 is equal to 40,000 plus n minus D is 2500. So we get the value of n is 11. So we are saying that the 11th annual salary received by Tanvi will be 65,000. That is, it is after 10 years. So in the year 2025 her annual salary will be 65,000 rupees. Next we have, in a new year Renu saved rupees 50 in the first week, and then increased her weekly saving by, first week she has saved rupees 50, then she has increased her weekly saving by 17.50 rupees. Next it will be 17.50 more. We are saying likewise we have to find in which week her saving will be 207.50 rupees. So the value of A we have it is 50, D is 17.50, and T and we have it is 207.50. So we get 207.50 is equal to A plus n minus 1 into D. 1, the value of D we have it is 17.50. These calculations are shown over here, that on solving these values you will get that the answer for n is 10. You can verify this answer at your own, that the answer you are getting it is 10. So we are saying that Renu's weekly saving will be 207.50 rupees in the 10th week.